So now let's start deep diving into assessing your problem hypothesis, your research design, or your startup concept. We will start with the external assessment first. And remember, there are 4 C's to that. Let's start with the first C, which is assessing the category for problems that may exist in the category. And we'll look at some examples of successes where the category assessment was done well by certain large companies or startups. So let's look at some of the key questions you may want to ask and discover and reflect as you assess the category. So there are some questions on the screen. And as you look at the screen, think about how the category of music itself has evolved. Think about how the very first rendering of music was peer-to-peer. You sang, I listened, or I sang and some of you listened, and this was all in physical presence. And then the radio came in when you could broadcast. Then the records came in, vinyl records. Many of you may not even have seen vinyl records, but the records, large vinyl disc where you could record music, and music could then be spread across. Then tapes came in, and the spool tapes and then small tapes. And then the category of music moved from tapes to CDs and DVDs. And then from CDs and DVDs, it went to memory like on your phone. You could store the music on your phone or an iPod. And today, if you look at it, the whole category has moved away from even storing the music on your phone into over-the-air streaming. So you could go to Ghana or any of the streaming music apps. So as you look at those questions that you see on the screen, this will help you assess how the category is moving, and are there opportunities for you to discover a problem in that category and solve that for your research purpose or to do a startup. I'm not going to read the questions on the screen, but instead I will share with you a few more examples. So if you look at Tata Nano, a few years back, Mr. Ratan Tata wanted to create a new category of very small cars, which he was hoping would replace a whole family traveling on a scooter or an auto rickshaw in India, which is very common, into a very small car which was affordable and marginally more expensive than a motorcycle. And Tata's launched the Tata Nano with mixed results. But that's a good attempt of a Tata conglomerate trying to move the category from richer, bigger cars into very affordable and very small car. If you look at Apple in US, Apple changed the concept of a phone from only communication to a whole ecosystem. So you could take very good pictures. You could listen to music. You could have a whole app store with millions of applications, and all of those functions you could do in the phone itself. And therefore, the category of a phone went away from being just a communication device into almost an all-in-one device. And think about how much time you and I are spending on the phone today. If you look slightly earlier into a product called Walkman, which came out in the 80s, what Sony successfully did was made the music mobile. Before that, you could listen to the music in large record players or large tape recorders, but you could not carry your music with you. But with the Walkman, you could carry your music because it's a small device and you could put a headphone on it and listen to it. So music was suddenly in your pocket. And then Walkman went on to iPods, MP3 players, and then you could move your music into your phone, store them, and listen to your music on the move. And today, you've got the OTT platform. Even in simple things like shoes which are working basically as something to walk on, suddenly became an athletic aid which are used in Olympics and professional sports, because the simple shoe suddenly became a far more sophisticated product and the whole category got upgraded. But think about it. Each of those category movements wanted to address a certain problem, some successfully, some not so successfully. So if you look at Tata Nano, how to move people more safely from a family riding on a motorcycle to family running on a very small, affordable car. How do you move the music into your pockets? How do you move shoes from being just for walking into an athletic aid? And this is how your problem statement may actually work on redefinition of an entire category. Let's now look at the next C, which is assessing the country. As I've shown earlier, the entire country may be impacted by a certain startup or by a certain product or a solution. And as you can look at the questions on the screen and how to define a country level problem, think about what has happened in India. As payments move from credit cards, debit cards, cash into UPI. And today, lots and lots of Indians are using billions of transactions only on their phone. So the entire country and almost 1 billion people have moved from a certain type of payment into another kind of payment. So this is working at a problem which impacts the entire country. And there's some more problems which you can see on the screen, some more questions that you can ask. But as you think about the problems, let me also talk to you about a few startups and companies which have actually impacted the entire country. In India, we've talked about Jio. Jio started as a telecom provider, but Jio moved on to entertainment. So we've got Jio Cinema. It moved into online commerce. And therefore, suddenly, you have got a convergence of hardware, software, which is changing almost the nature of the country simply because of the vast presence of a company like Jio. If you look at other countries, US and increasingly other countries, even India, used to do most of its shopping in small stores, what in US they call mom and pop stores, in India which we call kirana store. We'd buy our products from a kirana store. And then the big stores came, Walmart or Costco or Target. In India we have Star Bazaar and Big Bazaar. And then the e-commerce platform came. So you had Amazon, which came out of US. You've got Flipkart, which came out of India. We've got Mantra, Tata Neu, etc., or Nykaa. And these problems, as they get solved, are impacting the entire country. Japan, a company called Toyota, and then other automotive companies, started an inventory management system which was just in time, which helped improve the efficiency of how inventory was managed as automobiles were being created. Similarly, in Germany, a company called Bosch impacted the entire automotive component business of that country. And now to encourage each of you to do your own search, your own discovery, and reflect how you can define a problem which impacts an entire country. The next validation point for a problem statement or a research hypothesis or a startup is to assess it from the point of view of the customer. So put some of the questions that you can look at when you're trying to look at the problem from the customer's point of view. But think about how the needs of the customers evolve. And if I go back to a very basic problem, human problem of moving from point A to point B, think about how human beings first used to just walk. If they wanted to go from point A to point B, they would walk. Then they found the horse, and they would ride the horse or a mule. And then when the wheel came up, they invented the chariot or the wheeled cart. And then once the locomotive engine came up, the combustion engine came up, cars came up, then scooters came up, then planes came up, trains came up. And with that, the customer need of moving from point A to B was met, because now A to B would not be just a few kilometers. It could be thousands of kilometers. It could be the other side of the world. And now we have people going out on spacecrafts or hyperloops. So this is how there are dimensions to a fundamental problem which keeps evolving over time. And there are some questions here, and there are a few more pointers which you should reflect as you examine your problem hypothesis or your startup or your research problem design and look at it from a customer point of view. And here are some few cases which you may want to look at. Again, these are big cases, big brands, big companies, so it'll be easy for you to research. So, Flipkart, one of the challenges in India about a decade back was how do we pay for the goods that we have received? Because Indians were not really used to paying to a company prepay a company for a good that they have not received. We are more used to going to a shop and look at a product, get the product, and pay the money. And companies like Flipkart came up with this concept of cash on delivery. And with the cash on delivery, the whole e-commerce adoption went up. So Flipkart in India, Amazon in US started moving the business from physical stores into online stores. We have talked about moving entertainment from the television, videos, or tapes into streaming services. But if you look at Netflix and some of the other OTT platforms, they also use a lot of intelligence to provide you with a steady stream of entertainment options, which is what you like. And this is also true for reels that you watch on Instagram or Facebook or TikTok or any of the Indian local OTT platforms. Because you always get a recommendation for the next watch or the next listen or the next read or the next buy. So recommendation engines. If you look at the fashion category, there are a lot of companies you can research, like Uniqlo or Zara, which have worked on the problem from the customer side, because a lot of customers want the latest fashion or the latest product versus what everybody else is wearing. Similarly, in the cars, companies like BMW, and then if you go up the ladder, Rolls-Royce, etc., started looking at it from the customer point of view, where you could actually choose every aspect of the car. So it's no longer just a few color options or a few engine options or a few size options, but you could actually customize it with hundreds of different attributes. And therefore, you have defined a problem from a customer perspective. Let's move on to now looking at problems from a competitive angle. Whether you're a startup or you are a large company or you are just doing a research in a research lab and trying to build a prototype, a lot of times you have to look at the problem from a competitive angle of what already exists. And one of the latest, and then we'll get into more example later on, for those of you who are using Gen AI, which is large language model kind of AIs, ChatGPT, most of you will be familiar with, came about 12 to 18 months back. And soon as ChatGPT came from OpenAI with Microsoft support, Google launched their Gemini, and a lot of other companies came up with other versions of generative AI, large language models in France and China, and there are some coming up in India as well. So when you're working on a problem pool framework for research or startups or even your big company product launches, it's very important that you look at it from a competitive lens. And here are some questions which will help you do that, to look at it from a competitive lens. But let me also give you a few case studies which you should investigate and reflect on. Some of the well-known ones, if you are in India, is a competition between Ola, which is an Indian startup, versus Uber, which is a US startup. You also have Oyo and Airbnb. And then there are competitive aggregators in different fields. If you look at Google and Microsoft in cloud computing, and those of you who are into gaming, remember before all the games moved onto the smartphone, there are also consoles from Sony, Nintendo, and Microsoft, where you to have a very good feel of what exactly the competition is doing because you are reacting and trying to stay ahead of the competition. And this is across all domains, including automobiles, such as Audi versus BMW or versus a Mercedes. Or even at the low-tech industries like Coke and Pepsi, and soaps and shampoo from Procter & Gamble and Unilever. So you have to look at the problem from the competitive lens as well. We have now looked at a structured framework to assess problems externally, assuming you have adopted the problem pull methodology for research or starting up or in your own company to launch new products. So as I've said earlier, there are 4 C's for internal assessment. And the first of them is around capability. Why is capability important? Because if you adopt a market pull approach, you have to have the capability to develop a product or solution or to research and be able to meet the problem that you have identified. Whether you are in a research lab or an academic institution or in a company with an R&D budget, you may have identified a problem, but if you don't have the resources or the training or the capabilities or the equipment, you will not be able to solve that problem that you have identified. So you may look at some of the questions that are on the screen for internally assessing your capability as you do a problem pull kind of a startup or a research project. I'm now going to share a few pointers of large companies which are there in the public domain, which you can research and reflect on how a lot of big companies and startups have to build the capability to meet problems that they have already identified. So if you look at India, many companies like TCS, Infosys, Wipro, etc., which had a certain business model, and as new generations of AI is coming in, Gen AI, LLM, large language model, etc., coming in, are having to rebuild their capabilities as new technologies are coming in. If you look at US, the chip design or the chip maker called Intel, which most of you will know of and probably using it in your laptops, they've continuously got to build the capability to develop the chip capabilities. First, in terms of efficiencies, microns, 10 micron, 7 micron, 8 micron, 5 micron, 3 micron, but also building in new kind of capabilities like an AI or a graphics processor into their mother chip. If you look at Panasonic, for example, a large entertainment company, they have to continuously build the capabilities for newer generation of entertainment options, devices, products. If you look at the cloud companies, or even companies like SAP, or Amazon Web Services, or IBM Watson, they're also continuously building the capabilities as the problem in the marketplace changes. So kindly research, discover, and reflect on this aspect. Let's look at the next C, which is around collaboration. You can look at some of the questions on the screen, but if you think about it, let's look at what's very top of mind for many of us: electric vehicles and batteries. If you look at a battery, the new generation of lithium batteries which are powering the electric vehicles, it needs a lot of cable. The lithium battery itself needs a lot of capability. It's mining to be able to extract lithium. It needs metallurgy to process lithium. It needs some chemistry. It needs some physics. It needs electrical engineering, and it needs mechanical engineering, and it needs chemical engineering. So suddenly, the products are not as simple as in the earlier days. And not one company, not one startup, not one research lab, not one researcher, nor even one faculty may have all that it takes to research or develop a new product. So as you do the problem pool methodology and identify a problem, you need to also assess the problem that you have identified from a collaboration point of view as to who all do you want to work with to develop the final research output or the final product. And again, to give you a few pointers, even large companies where you have a lot of public domain knowledge and you can actually go and research themselves, collaboration is happening across. So the most famous would be OpenAI and Microsoft for the ChatGPT. Even in India, companies like TCS are working with startups to identify and build in new capabilities into their existing business model. If you look at the defense sector, Boeing, or our own Indian projects around Tejas, or our submarine plants, or a main battle tank, or a spacecraft, there's not one company, one lab which is doing it all. It is a collaborative effort. If you look at automotive, car manufacturing, Tesla, or some of the Japanese ones like Honda or Toyota, or the German ones, it is a lot of collaboration between companies and labs who have different capabilities. And the finished research or the finished product or the finished prototype needs multiple technologies. If you look at healthcare, again, it needs a collaboration between companies who are making the device, have the health analytics, or have certain parts of technology. So as you do the problem pool and identify a problem hypothesis, it's very important that you also look around for who you can collaborate with to solve that problem. The next C is around assessing your problem for convergence. Because a lot of technologies are converging to create new products. And a lot of research problems need to cover many different technical aspects, engineering aspects, or science aspects. You can look at some of the questions for evaluation. And I'm also putting a few case studies which you can deep dive into. We have talked about telecom, entertainment converging into one seamless solutions. We have talked about the smartphone becoming almost like a switchblade, where you can do many things with one device. We have talked about electric vehicles or electric batteries, where many technologies converge to create the final product. We have talked about healthcare and devices, again, where you need a whole bunch of technologies, sensors and plastic and new material science to come up with the devices. If you look at smart city, that project, the problem of creating smart cities need many different and complex technologies to solve. The last C is a bit of a soft C, which is around cognition. Because not all the problems can be solved with only the harder aspects of technology. You also need to build internal capabilities within yourself, like empathy, like understanding the customer's problem and solving it not only from a technology point of view, but also from a behavioral, usage, emotional point of view. Think about it. Lot of times, a technical product like a car or a phone, or even a simple product like a soap or a shampoo, is very difficult to tell them apart. Yet, some have preference for one type and some have preferences for another type. And many of them are not directly technology, but on the human emotions. Internally also, to capture the nuances of human behavior, human needs, you need a team which is probably multifunctional, including members in your team who understands the softer aspects of human behavior. So again, I put up some questions on the screen which you can look at. But if you look at some examples which you may want to research and reflect on, there are many examples. For example, drugs, medical drugs, or if you look at the COVID vaccine, there are a lot of soft aspects about the COVID vaccine itself, because there are many people who are kind of a bit scared, a bit apprehensive about the after effects. There's some controversy whether it's good, not so good, etc. So these are nuances that you need to take care of. If you get into AI, there's a lot of nuances in terms of ethical, non-ethical, usage, non-usage. If you look at social media platforms, there's a lot of debate about how much social media is too much. There's debate around fake news. There's debate about alternate news channel and alternate realities. So when you look at a problem, it's not only the technical part of the solution or the problem, you also need to look at the human effect of the problem as you define it, as the world becomes more and more complex. So with this C, we have concluded the 8 C's of a good problem discovery framework, a structured framework, a disciplined framework to assess your problem hypothesis, your research hypothesis, or your read of the market or the competition or the category. Let's move on to some other topics related to problem pull and problem discovery. So if that was the 8C problem discovery framework, who can benefit from use of such a structured problem discovery, problem pull kind of methodology? Let's look at the academic community. I would suggest that a lot of faculty, be it school, undergrad, postgrad, be it a theoretical program or a do-it-yourself or a laboratory program, may want to incorporate a problem-solving framework into the curriculum, because I think there are a few benefits which I've tried to capture on the screen. Because whatever be the course, whether it's physics, chemistry, mathematics, economics, humanitarian, biology, material science, innovation, entrepreneurship, I think whatever be the course and the curriculum, having a line of sight to a real world problem may give the student, the researcher, the benefit of a real world sense. It may also lead to a few other benefits, such as a broader perspective in industry, in academia, in research labs, in a country, outside a country, and also stimulate. Once the student understands that problems cannot be solved in just one dimension, with just one course, with just one domain, it may open the students up for more interdisciplinary thinking. A broader, structured problem definition can help the researcher write a more relevant paper, file a more workable patent, build a more customer, company, category-oriented prototype, and also encourage the researcher to look beyond any one country, to look at a global perspective and look at the nuances of the problem around the world, and also collaborate with other researchers. From an industry perspective, I think a structured problem discovery framework can impact and help industry professionals, especially those who are working on building the brand. The failure of new product launches, and I'll share with you more data in the later sessions, is as high as 90% plus. And a lot of the failures is driven by a problem which is probably not defined well. And I've tried to capture on this slide some of the benefits which the HC problem discovery framework may offer to a brand manager or a product manager or a category head. Apart from brand, product, and category heads, a structured problem discovery framework is probably of critical importance to R&D heads. Because an incompletely defined problem, or a problem which doesn't look at all the nuances and the aspects of the HC framework, may lead to a great research outcome of a not so great problem definition. So it's a brilliant solution to not a brilliant problem. And that in the long term is not of benefit to the company or the customer or the shareholders. Finally, looking inside the company, I would recommend that even the leadership, be the CEO or the CXO, the head of marketing, head of production, financial head, also have a look at how the company is allocating resources and funding to problems which, when they are solved, have a real world impact, have an impact on the revenues, and are also profitable. So I think this is of merit to the company leadership as well. Finally, for entrepreneurs who are starting to do a new technology venture and create their new company, finding the right problem to solve is an absolute must. Because as an entrepreneur, if you start working on a problem which is already solved in some other part of the world, in some other form or shape, chances are your startup will struggle or not get funded. Again, I've tried to capture some of the benefits of this problem discovery, of the problem pool approach for entrepreneurs. So how do we drive adoption of the 8C structured problem discovery framework? I would recommend that we look at the usual ways of driving this in the academic or the industrial settings through a few awareness building workshops, through a few seminars, through a few early adopters who try to use this framework, and if they see value, they can do word of mouth spread. I'd also recommend that the research lab head or the R&D head or the CEO or the CXO or the founder or the co-founder use this framework as they work with their teams to validate the problem hypothesis. And hopefully with that, we will see that the better and more focused problems are being defined, which then will lead into my next session on how do you build great products. And in conclusion, I'd like to talk a little bit about what are the skills that you may want to develop, which will help you leverage this framework well. And I've listed some of the skills on the screen, but it starts from a little bit of curiosity, a lot of big picture thinking, data analysis, talking to customers, researching competitors, looking at external reality and internal capabilities, developing some financial acumen so that you can quantify the magnitude of the problem. Also sharpen your ethical regulatory awareness. So when you define the problem, you can also look at it from a regulatory or an ethics lens. Also the risk, especially if you're doing a deep tech, higher gestation kind of a problem solving. So with that, we come to the end of this lesson. And the next lesson is about how do you create great products, great prototypes, great research outcomes, great patents, etc., based on a great problem discovery. Thank you. Namaskar.